It's time for another amazing chemistry video with Mr. Stapleton. Grab this one, sit back, I'm doing a nice coffee. Hi guys, welcome to the 6th video in the Organic Chem series. This one's going to be all about amines. Okay, now the reason I've got a smelly fish logo on here, I just found this online. It's actually a font that a guy's done, so I think this is actually the smelly fish font. So shout out to him. If you want to download it, I'm sure he'd appreciate the service that you're paying for. But the reason I put a smelly fish on there is because that's one of quite of the characteristic things about amines, is that they have an unpleasant odor which smells a little bit like rotting fish. Okay, so score for amines. So the amine functional group is actually a nitrogen atom. Now, quite often what you'll see people drawing an amine functional group is like this. Okay, that's actually a primary amine, NH2. Okay, so the functional group of an amine is a nitrogen. So you can see in a primary amine here, we've got 2 hydrogens attached to the nitrogen. Here in a secondary amine, we've got 1 hydrogen attached to the nitrogen. In a tertiary amine, there's no hydrogens attached. So histamine here is really good. You may know people that take antihistamines, for example, like if you're stung by a bee or anything like that, so they're in your body. So you want to stop your histamine buildup when you get stung. And histamine actually has all 3 types. So here on the end we have a primary amine. Okay, here as part of the ring we have a secondary amine, and this here is a tertiary amine. So you can see all 3 of those, and you can see the difference in the number of hydrogens in there. Now, you can hydrogen bond off of this. Remember, a hydrogen bond needs a hydrogen attached to an electronegative oxygen or nitrogen. But nitrogen isn't as electronegative as an oxygen, so this bond is actually less polar than the OH bond. So what that means is that the hydrogen bonds that these form with each other are weaker than you'd find in an alcohol. Alright, so the boiling points of the amines are lower than the corresponding alcohols. They're still higher than the corresponding alkanes because you've got this ability to hydrogen bond. Okay, but it is a weaker polarity group here. Okay, solubility is pretty good for the first couple, and then as you increase the carbon chain length, as with any other homologous series, the solubility decreases. Now, amines, because the nitrogen has a lone pair of electrons on it, which you can see here, alright, and every nitrogen has that, that means it can act as a base. Alright, that means that lone pair of electrons can accept a proton, okay, and form a coordinate covalent bond, which is what you see here. Alright, so we get what we form the protonated amine. Now, protonated amines are really good because, like the carboxylate ions, with the sodium or potassium on it that we saw in the carboxylic acid video, when you have a protonated amine, it actually allows for ion dipole interactions with the water. Now, those ion dipole interactions make the molecule water soluble. So here we've got a very large organic molecule. All right, we don't have any carboxylic acid groups in here. What we've got is one alcohol group there. Okay, we've got a ketone over here. We've got an ether group here. This is actually an amide group, which we'll cover in the following 2 videos time. Okay, and we've got an aromatic group here. So it's a very, very non-polar molecule. What we do have here is a nitrogen, so this hopefully you can work out is a secondary amine. And what we could do is we could actually protonate this amine. Okay, now we protonate it, the nitrogen gets a positive charge, and it allows us to form ion dipole interactions. So acetobutylol is what's called a beta blocker. It helps treat high blood pressure here, and what they do is convert it into an ammonium salt here, which you can see, and that allows it to be water soluble. So it's a very, very useful property in medicine because you're not always going to be able to have carboxylic acid groups. Quite often you'll have nitrogens in there, and if you protonate them, you can get that ion dipole interaction. So the proper terminology is called a protonated amine, right? And that allows those ion dipole interactions. So really what they're going to ask you about amines is simply this. They're going to ask you to be able to draw the protonated form of these amines. And it's pretty straightforward, really. I'm just going to show you the first couple. So with this one, with your CH3 group here, okay, again, I apologise, I'm drawing with a mouse, so it's not that nice. I'm not drawing on my other laptop where I can draw a bit more nicely. Okay, you got your N, Okay, what you're going to do is you're going to put your normal 2 hydrogens in there. You're going to put another one on, and it's really important for this that the positive charge goes at the nitrogen, because that's where the positive charge is. Don't draw it on the hydrogen, because that would be incorrect and they'll mark you wrong. Okay, so put your positive charge on the hydrogen. So you just got to do the same thing for all of these. So this one's really simple. You can just put a hydrogen there, for example, and the positive charge goes on the nitrogen. Okay, same thing over here. Put your hydrogen there, positive charge on the nitrogen. Put a hydrogen here, up, down, sideways, backwards, doesn't really matter. Okay, put a positive charge in there. Same thing here, hydrogen there, positive charge on the nitrogen. Hopefully you've been able to see the trend here. Put your hydrogen in for the protonated form, put the positive charge on your nitrogen, and you've got your protonated amine, which allows you to form ion dipole interactions with water, which increases the solubility. As I said, that's basically what they're going to ask you in this topic. If for amines, if they put an exam question in there, draw a protonated form, or they might ask you to identify a primary, secondary, or tertiary amine. So make sure you can do that as well. In this examples here, maybe you might want to go through and identify which ones are primary, secondary, and tertiary. I'll answer it for you now if you want. So this one's primary, this one's primary, this one is secondary, that one is tertiary, that one is primary, and that one's primary. Hopefully that was pretty straightforward for you to work out as well. Alright, short video this one. Leaves you more time to drink some more iced coffee, and as always, ask questions if you've got them. Thanks guys.